Welcome to Math Concept in Answer. In these previous lessons, we have already discussed what is interior points, and today we will discuss what is limit point of a set. Suppose a real number L is said to be a limit point of set if every neighborhood of L contains infinite numbers of the set. That means every neighborhood for every delta greater than 0, L minus delta and n plus delta intersection is an infinite set. That is the definition of the limit point. Suppose this is real number system, this is S, and let L is called limit point if a neighborhood of L minus L plus delta and L minus delta contains infinite number of elements, then we called L is a limit point of the set. Limit point is also known as the cluster point and the accumulation point, that is also called the limit point. So what is the limit point? If we revise it, L is said to be a limit point of a set S if every neighborhood of L contains infinite number of set. That is called the definition of limit point. If we focus the alternative definition of limit point, then suppose L belongs to R and S subset of R, then we say L is a limit point of a set S if every deleted neighborhood of A contains at least one element of S. What is deleted neighborhood? If you do not watch my previous lesson, please watch and link in description. So that means every deleted neighborhood of A, that means the neighborhood which is every deleted neighborhood of A contains at least one element of S. That means S intersection with L minus epsilon L plus epsilon, which is minus exclude L, that is not equal to phi. This is the definition, alternative definition of the limit point. So S intersections L minus epsilon L plus epsilon minus L not equal to phi. So now we will focus on some result on the limit point. If we consider a finite set, then we clearly see that it has no limit point. As finite set, the set is finite. So L, the neighborhood L minus epsilon L plus L minus delta or L minus epsilon, this neighborhood contains only the finite number, since the set is finite, but we have, this is a infinite set, so finite set has the no limit point. But also infiniteness of the set is only necessary condition for a set to have a limit point. Infiniteness is the only necessary condition for a set to have a limit point. As it is not a necessary and sufficient condition, it is only the necessary condition. As if we consider the natural number system, then we get that this is, suppose 1 1 2. So if we consider an neighborhood of delta 2 plus delta and 2 minus delta, it contains only finite number of points. So infiniteness of a set not only the necessary condition for a set to have a limit point. Now the third property of a limit point may or may not be belongs to the set. Suppose S is a set that is open 0 close 1, that is if we consider 0 and 1 and all the points between 0 and 1 are the limit points, but 0 not belongs to S. So limit point may or may not be belongs to the set. Now the next concept is the collection of all limits points of a set. The collection, if we collect the all limits points, then we find a set that is called the derived set of S. That is the collection of the limit point is called the derived set of S and denoted by S dash. That is S dash. X belongs to real number. X is a limit point of S, where X is a limit point of S. As we have already discussed that limit point must belongs to the real number, not belongs to the S, the set. So this is called the derived set. So basically a real number L is said to be a limit point of a set if every neighborhood of L contains the infinite members of the set, and the collection of the all limit points is called the derived set. That is our next. We will focus some derived set, some set and their derived set. If we consider the open interval AB, then the derived set is closed interval AB, and that means A and B are the also limit point of this set, and closed interval AB, this is also the derived set closed interval AB, and open A and close B, that is close AB. If we consider the natural number system, then we called that it has no limit point, because if we consider the natural number 1, then we find that in the delta neighborhood it has the only one point, that is 1, which is not infinite. So natural number is 5. Rational numbers, limit point of rational and irrational number is the real number system, as every neighborhood of real number contains infinite number of the rational as well as irrational number. So limit point of the irrational is R, and limit point of R is R, that is R. Now we'll focus an important result, special result for a derived set. How to find a derived set? Important result about the derived set. We have suppose a set that is in the form x plus 1 upon n. X belongs to A and n belongs to n, where A subset of R, where A subset of R. Suppose we have a set in the form S equal x plus 1 upon n. X belongs to A and n belongs to n, where A belongs to A subset of R. Then the derived set, then we call the derived set of S dash is A union A dash. A union A dash is the derived set of S dash. If we consider the example about this, that is S equal to x plus 1 upon n, where n belongs to natural number, x belongs to q. Then the derived set will be S equal to A union A dash, here A equal to rational number, so q plus q dash. So q union q union q dash, that is q union R. So that will be obviously real number system. So S dash is R. So this is very special result to remember us if we want to find the derived set of form x plus 1 upon n, then we find the derived set is S dash equal A union A dash. Now focus on the next example, that is S equal M plus 1 upon N, that is M comma N belongs to natural number. Here A equal to natural number, so A union A dash equal to natural number union phi, as the derived set of N dash equal to phi. So this is obviously the natural number system. Now focus on the next, that is S equal to 1 upon M plus 1 upon N, where M and N belongs to natural number. Here we find that A equal to 1 upon M, M belongs to natural number. Here that is A dash equal to 0, A dash equal to 0. So S dash equal to A union A dash, that is 1 upon M, M belongs to N union 0. That is our the derived set of this set. So in the alternative manner you can find A equal to 1 upon N, so you will easily get the answer. So now the next thing is, what is the limitation of this result? What is the limitation of this result? That is very important to us. If we apply the result in case, so it is very important to know what is the limitation about it. Suppose x and n both are the same, x and n, if x and n both are the same and belongs to the natural number, then the result is not applicable. Important, it is very important. If x and n both are same and belongs to natural number, then the result is not applicable. That means n plus 1 upon n, n belongs to natural number, where s dash equal to phi, s dash equal to phi. So thank you for watching. Next